So hello everyone. Today I will discuss the all four problems of the weekly contest 468. So move on the first problem and see what it says. So basically you are given an integer array nums, return a bitwise or of all numbers in the array. So basically it says you are given an array nums and you need to return all the bitwise or of all the even numbers. So you are given here the all the nums, all the elements of the array nums, and you need to return the bitwise or of all the even numbers from this nums. So here the even number is 2, 4, and 6. So on taking the or, you need to return that answer, which will be the 6 here. So this is pretty simple. So again, if there is no even element in the nums, then you need to return the 0 as an answer. So move on each element and check is there any element is even or not. If that element is even, then take the XOR or of bitwise or of that element. So move on the code. Mm, So in the problem, it says the nums, but I take that array as nums as ARR. So n is the size of the array, and I will initialize to the initial answer as a 0. So I will move on each element one by one and check if any element is even. Then I will put that into the answer by taking the OR, and after it I will return the answer. So that is all for problem number 1. So move on the second problem and see what it says. So in the second problem said you are given an integer array nums of length n. So basically you are given an integer nums whose length is n and an integer k. And an integer k. You need to choose exactly k non-empty subarray nums of L to R of nums. The subarray may overlap and exactly same subarray, same L comma R can be chosen more than once. So notice here, same L and R can be noticed can be chosen more than once. So basically, it says that you are given an array nums, and you need to select k, k non-empty subarray, and in that subarray, all the subarray may be equal, or maybe one subarray equal means two subarray equal, or three subarray means any number of times any subarray can be chosen. The value of a subarray nums of L comma R is defined as the maximum of nums of L comma R minus minimum of nums of L comma R. The value is the sum of values of all the chosen subarray return maximum possible total value of you can achieve. So let's see here. So basically, let's say the our array is 132. So basically, our array is 132, and value is of k is the 2. So see here, the array is the 132 and the value of k is the 2. Yeah. So you need to choose any k length any you need to choose any length of the subarray two times. So let's say I will choose to all the complete the array two times. So on the first time I will pick to this subarray and I will take the maximum of this subarray which is the 3 and the minimum of this subarray is 1. So the value of this subarray is the maximum minus minimum of this subarray which is the 2 which is the 2. So again I will pick the same subarray for which the value of that subarray will be the 2. So the total sum of the subarray will be the 2 plus 2 which will be the 4. So you can verify from there. Yeah. So give the second test case. So in the second test case, the array is 4 to 5 1 and the value of k is the 3. So the array is the 4 to 5 and 1. 4 to 5 1 and the value of k is the 3. So you pick all the means complete the subarray first time. So in the first time, if you choose complete this subarray, so the value of that subarray will be the maximum of this subarray minus minimum of this subarray, which will be the 5 minus 1 will be the 4. Again, you will choose the same subarray again and again till 3 times. So after it, the total value of the chosen subarray will be the 4 into 3 because you choose 3 times and each time the value of the subarray is the 4. So the final answer will be the 12. You can see from there. Yeah. So move on the code. So basically you are given an array nums, but I take that nums as ARR, and you are given an array k, an integer case. And here n is the size of the array, and I will initialize to the maximum and minimum and move on each element and pick the maximum and minimum. So move on the complete array and find the maximum and minimum value from the complete array. After it, I will go from the on each k, means I will move till k times, and at each time I will add maximum minus minimum, which is the value of that current subarray, into the answer. You can see from the here. I will pick the first time subarray with value 4 and again the second time with value 4, third time with value 4. So the total answer will be the 4 into 3. You can also can get answer like this, or you can move from on each k and add 4 into the answer. So here I will go k times and at each time I will add to the maximum minus minimum into the answer, and after it I will return the answer. So that is all for second problem. Move on the third problem and see what it says. You are given two integer nums1 and nums2 each of length and you may perform the following a split and merge operation on nums1. So basically you are given two arrays nums1 and nums2. So basically you are given two arrays nums1 and nums2 and you need to perform a split and merge operation on nums1 so that it can become equal to the nums2. And the split and merge operation is look like choose a sub array from nums1 and remove the sub array and then reinsert the removing sub array at any position in the remaining array, that to say any between any two element at very start or at very end. Okay. Return the minimum number of split and merge operation need to transform nums1 into nums2. So basically you are given a two arrays nums1 and nums2. You are given two arrays nums1 and nums2 and you need to make the nums1 equal to the nums2 after performing an split and merge operation on nums1. The split and merge operation is look like, let's say if you have the array 1 2 3 4 5, then choose any subarray. Let's say if you choose the subarray with 1 and 2, then the remaining subarray will be the 3 and 4. Then the remaining subarray will be the 3 and 4. After it, you need to put this subarray, this remove subarray 1 and 2 at any place of the remaining subarray 3 4 5. 3 4 5 is the remaining subarray and 1 and 2 is the removed subarray. So you need to put the remove subarray at any position of the remaining subarray. Let's say if you can put to 1 and 2 at this position or this place or this place. Let's say if you choose to this place to put the remaining subarray, remove subarray, then the array will look like 3 4, the array will look like 3 4 1 2 5. So after it you can perform the more operation on it, or you can, or you find the answer which is equal to nums2. So you need to, after it, the each split you need to check is there equal to the nums2. If it is equal, then return the minimum number of operation to make the arrays equal to the nums2. So move on the constant. So here you can see constant is pretty low, which is this maximum 6. So you can think about the brute force solution. So say here, pick on the first test case where the nums1 is the 312 and nums2 is the 123. So nums1 is the 312. I verified. So nums1 is the 312 and the nums2 is the 123. So you need to find the minimum number of operation at which you can make to the nums1 into the nums2 by performing the split and merge operation. So let's say if you choose to this element 3, and after it the remaining subarray will be the 1 and 2 and the removed subarray will be the 3. And if you place to this removed subarray at this position, then you can become 1, 2 and 3, which will be the equal to the required subarray nums2. So here you take one operation to perform it. So think about this, what you can apply here. So you try all the subarray. You not know the which subarray gives the perfect answer. So think brute force way. Think in brute force way and choose all the subarray. So if let's say if you have the subarray 312, so what's the total subarray look like? The let's say if you start the subarray from this index, then the total subarray starting from this index will be 3, 3 1 and 3 1 2. If you choose to this element as a starting index, this index is a starting index of this subarray. So the one subarray is the 1, second subarray will be the 1 2, and let's say if you want to choose this subarray starting from the this index, so there will be only one element. So how to find the total number of subarray? So to find the total number of subarray, what we say, what we do, you pick the each element, means you go on the each element and move on the each index after it. Let's say here the here is the 312, and let's say you are at this index. Let's say this will be the left index L. So what you try to do, you pick either this subarray, or you pick this subarray, or you pick this subarray. Means either you at this index, or at this index, or at this index. Means go on the each index from L 0 to n minus 1, 0 to n minus 1. Basically, go on the from each element 0 to n minus 1, and for each element, what you do, for each element, you go on the r equals to L to r minus 1, means n minus 1. Here, if L is here, then r can be here, here, here. So try all the subarray, go on the from 0 to n minus 1. After it, you go from the inside this, go on the r equals to L to n minus 1. And then the subarray will be the from L to r. And your subarray will be from L to r. And you need to remove this subarray and place it any position in the remaining subarray, and you need to find the minimum number of operations to make this array equal to the nums2. So for this I will take the help of the queue data structure, which will store in the FIFO order, which is the first in first out. And in the queue, what I store the current array I store the current array and the number of operation to make that and number of operation required to make this current array. So initially the given array is the nums 1 and the operation will be the 0. So initially I will push to this into the over the queue, and to to put the unique array in the queue, I take the an array map which is the as the array that tells the our array is visited or not. So move on the code. So first I will take the nums1 as the name ARR, and here n is the size of the array, and initially let's say if the given both nums array is equal, then the return simply 0, either it. After it you take a queue which is the store the vector and int, and take the map for the nums1 and 0 which is the number of operation to make the nums1 as a 0, and pick the first element means first array from the queue, and find all the subarray and that array, and after picking any subarray store into the new array. So the subarray will form the L to R, and put all the elements from L to R in order in new array which is the subarray chosen by you, and find the remaining array and show in the rem ARR, and go on the each place, and see at which place you place to the next chosen subarray. Either you can place on the 0th index, first index, second index, and after it you check the new array will be the equal to the nums2 or not. If it is equal, then the remaining answer to make the ARR means to make the previous array, and there is the one extra operation occurs, so return the answer plus 1, and check either it check the new found array is already visited or not. If it is not visited, then again put into the queue and mark as true. So that is all for third problem. You can see again here, and so move on the fourth problem. So see the fourth problem. The fourth problem said you are given an integer array nums of length n and an integer k. You must select exactly k distinct non-empty subarray may overlap, but the exact same subarray cannot be chosen more than once. So this problem is same as the previous second problem. So here what it says, you are given an integer array nums and of size n and an integer k, and you need to choose k non-empty subarray, but that all the k subarrays should be the distinct. But in the previous second problem, that says the subarray may be equal, but here is the catch: the value of subarray should be the means you choose you cannot choose exact same subarray, and you need to find out the value of subarray is defined as the maximum value of that subarray minus minimum value of subarray. The total value is the sum of the value of all chosen subarray. Return the maximum possible total value of you can achieve. So pick the first test case where the nums is the 132 and the value of k is the 2. So you need to choose two distinct non-empty subarray and find the total value of that subarray. The total value of that subarray is defined as the total sum of the total sum of the fusion subarrays. The total sum of the value of fusion subarrays, and the value of subarray is defined as the maximum of that subarray minus minimum of that subarray. See here, what about the maximum and the minimum of that subarray? So let's say if you have an array 1 3 2, and let's say if you choose here, if you have the array 1 3 and 2, and you let's say if you okay, the 2, and you choose to this subarray, choose this subarray 1 and 3, then the value of this subarray, the maximum value of that subarray, which is 3, minus minimum value of this subarray 1 and 3, will be the 2. So the value of this subarray 1 and 1 comma 3 is the 2. And let's say if you again choose to this subarray, so the value of this subarray will be the maximum value of this subarray minus minimum value of this subarray will be the 2. So the total value of that array means the total value of that sub, which is the answer, will be the 2 plus 2, which is the sum of all the sub arrays that you chosen, which is the unique sub array. So you can verify from there. The answer for this is the 4. Then see here the constant. So constant is like 5 into 10 to the power 4. So you can only uh, solve it into the big O of n or big O of L log n or big O of n root n. Big O of n, big O of n log n or in big O of n root n. So see here what you can see. You can also solve it. Uh, think about the root force. So what how you can think about the root force? So pick all the subarray and find the maximum and minimum of that subarray, all the subarrays, and pick the top k, means the subarray with means k subarray with highest value. But here is the catch: to find the that's all the subarray, it will take the big O of n square solution. That will not accept it. So think in optimal way. So pick the second test case and think how you can optimize it. Let's say if you have the array 4 2 5 1 1, and here is the value of k, means you need to select the non-empty subarray with the 3. So how you can optimize to the above solution? Think here. If you think about the some data structure like segment tree or sparse tree, so you can some analyze the pattern and you can find some solution. Basically, segment tree is a data structure that gives the solution of the each query. Let's say it will give the solution of the maximum and minimum of each L2R. So if you see here, if you find the maximum value of each range from L2R, then you can find easily the subarray with the highest subarray. So how you can find the key highest subarray? See here, the subarray look like the 4 2 5 1 1. So for it, I will use the segment tree that will give the maximum and minimum value of each query in big O of log n. So think how you can do it. So for it, I will take a priority queue. Why I will take the priority queue? Because we need to find the top k element whose value of subarray is maximum. So I will take the max if and I will store the value. What is the value of the elements uh, which lies between the L to R, and I will also store the range of the chosen subarray from L to R. And see here, if you pick the this subarray, then the let's say if you pick the only this subarray, which is the 4, then the value of this subarray will be the maximum minus minimum of this subarray, which will be the 0. If you pick this subarray, then maximum minus minimum means value of this subarray 4 and 2 will be the 2. And if you choose this subarray 4 to 5, then the value of this subarray will be the 3. And if you pick the this subarray, then the value of this subarray will be the 3. Sorry, the value of this subarray will be the 4. And let's say if you pick this subarray, then again the value of this subarray will be the 4. Then some pattern occurs here. You can analyze from here. What you analyze that if you move from any index L to R, and then if R is moved to the right, then the value of the subarray from L to R will be the increases. See here, the value of L 0, comma 0 is the 0, 0, comma 1 is the 2. The value of subarray from 0 to 2, which is the 3. The value of subarray from 0 to 4, which is the 4. The value of subarray from the 0 to means 4 to 1 here, which is the 4. So see here, if you are at index L, then the value of subarray from L to n minus 1 will be the greater than or equal to the, and which is also be greater than or equal to the value of from L to n minus 3 and so on. So if you start a subarray from at any index L, so the maximum value of this subarray will be from L to n minus 1. So what I will do, I will I will put all the subarray, all the means initially I will put the value of the subarray that is starting from the index I and ending at the index n minus 1. So for this I will take a priority which is the max heap, which is the max heap, and I will store in the max heap the value of each subarray from I to n minus 1, and along with I will also store the index which is the I and n minus 1. So pick the second test case and analyze how it will work. So the second test case is the 4 to 5 1, and the value of k is the 3. So initially I take a periodic queue, which is the initially which is with the empty, and initially I will take to the 4, and I will find the subarray value of the subarray from the 4 to 1, means the 0th index to you can see from on the basis of the indexing 0, 1, 2, 3. Then you can pick the subarray from the 0 to index 0 to index 3, and put the value and the index which is the L comma R. So for this, you can either take the vector, means periodic queue of vector, or you can take the pair of pair of int command. So I will find the maximum and minimum value, and I will for which I will take the value of this subarray will be the 3, and I will put into the periodic queue which is the 3, and the index will be the L will be the 0 and R will be the 3. So again, for this I will take to the this subarray, and I will find the value will be the 1, and index will be the from 1 to 3. Again I will take this subarray. Again I will take this subarray and find wait a minute, and find the value of this subarray and put into the queue, which will be the 4, and index will be the 2 and 3. And again I will take to this, which will be the 0, and the index will be the 3 comma 3. After it, the priority queue, the 4 will go in the top, and I will pick to the this item from the top of the priority queue, and here the value is the 2 and 3. Then I will perform one operation on this. After it, I will perform the other operation on this subarray, and but I will store the answer in the 4. So again I will pick to this, but after it I will move from the 0 to means 2 to 2. Why I will move from the 2 to 2. See here, if the L of see here, the value of L to n minus 1 is greater than or equals to the value of L comma n minus 2, and which is also greater than or equals to the value of L comma n minus 3. So after each picking element, I will move to the rather than the moving from L to R, I will move from the L to R minus 1, and again they perform the same operation, and after it find the answer till the k elements. Means I will pick the top k elements and perform this operation onto this, and after it I will return the our answer. So first you need to build this subarray. So after it, move on the code. So first I will build the segment tree. To build the segment tree, you need to take the segment tree of size 4 into n. So here you can see I take the segment tree. There is a two segment tree, max segment tree and min segment tree. Max segment tree is the segment tree to store the which is the array that will store the all the minimum value, means that will show the minimum value of all the queries from L to R. So I will call for the build function from the 0 to n minus 1, and here, from here you can build the segment tree, and after it I will to perform the query, means to find the maximum and minimum value, I will take query function, and I will perform the query on each L to R. What I will do after it I will take a priority queue that stores the value and the index, which is you can also call the as a range, that store the value and the range of that subarray, value and range. And after it I will go on the each element, and I will store in the priority queue the index I, means the value from that range from L to R, means which is the value of subarray from I to n minus 1, and that range I comma n minus 1, and I will pick the top k elements, and I will perform the minimum, and I will find the minimum and the maximum value, and again I will put into the queue. But here you need to ensure the L is lesser than or equals to the k, and I will decrease to the k, and at each step you need to put the value into the answer, and after it return the answer. So I can brief to it. First, I will build to the segment tree. After it, I will to perform the query. I will implement to the query function. After it, I will take to the priority queue, and in the priority queue, I will store the value and range of each subarray from starting from the index I, and after it, I will take the top k subarrays, means top k items, and store the value of that subarray into the answer, so that the our answer should be the maximum, and I will decrease to the r by the 1. uh, After it I will find the maximum and minimum of the current subarray, which is the L to R minus 1, and put into the priority queue. After it I will decrease to the k, and in final I will return the array and the answer. So that is all for